So this is the Unit 1A test study guide, and you'll need to do this independently yourself so that you can make sure you're prepared for the test. But I wanted to take a few minutes and do a short video where I worked a few problems from each section with you as examples just to make sure you were on the right track. So if we start out with the first section, I'm just going to read the directions and then work a few with you. The directions for the first set says, tell if each number is rational, irrational, or not a real number. Remember, rational numbers can be written as fractions. Irrational numbers cannot be written as fractions. They're non-terminating, non-repeating decimals. And then not a real number, those are numbers like where you put them in the calculator, it gives you an error. Things that don't exist or aren't possible. So for an example, when you divide by 0, you can't have 0 on the bottom of a fraction because it's not possible. If you tried to do the square root of a negative number under the square root sign, that's not possible. So those are things that would give you a number that's not real. So let's look at the first few. Let's look at number 1, negative 7/8. Well, negative 7/8 is already a fraction, so obviously that one would be rational. Number 2 is square root of 0.15. Well, anytime you have a square root, let's put it in the calculator and see what it does. If I put square root of 0.15 in the calculator, I get a decimal, and I'm going to just jot that down right quick, 0.387298335, and it stops because it runs out of room on the screen, so it would actually keep going. So that's a non-terminating, non-repeating decimal, which means that it's irrational. Number 3 is a square root of 18/2. Anytime you have a square root of something under the square root that's another operation, then you need to treat what's under the square root as if it's in parentheses, so it needs to be done first. So before I can take the square root, I want to do 18 divided by 2. So this is actually the square root of 18 divided by 2 is 9. And if we take the square root of 9, we know that that's 3. And 3 can be written as a fraction, so it would be rational. And you can continue on all the way down to 14 doing the same thing, just going through and marking rational, irrational, or not real. Okay, down to 15 is where the directions change. Find a real number between each pair of numbers. So anytime you're trying to find a real number that's between two numbers, all you have to do is average those two numbers in your calculator, which is done by adding and divide by 2. So if I take 7 3/5 and 7 4/5 and I add those together and then divide them by 2, well, I'm going to take the calculator and do that. 7 3/5 plus 7 4/5. That gives me 15 2/5. And then divide by 2. That gives me 7 7/10. And 7 7/10 is a real number, and it is between 7 3/5 and 7 4/5. Now, I will accept if you wrote that as a decimal. If you wrote 7.7, I would accept that. That's fine. I've had students turn these into decimals before, and that would be 7.6, and that's 7.8, and then they go and find a number between them that's a decimal, and that's fine too. I don't have any problem with that. As long as you give me a number and it's between these two, then I will count it. But that can be easily done by just taking your calculator and adding and dividing by 2. Okay, 17, 18, 19, those are just asking you to give an example of a number like that. Down at the bottom, simplify, that just means to do everything that you can to it, any operation that you can. So I'm going to just do number 1 right quick with you. We want to always, anytime we're simplifying expressions, we want to follow what's called PEMDAS, which means parentheses first, then exponents, then multiply, divide, and then add, subtract, and that's all from left to right. So the first thing I'm going to do on this number 1 is my parentheses. And inside my parentheses, I have square root of 144 minus 6. Now, the minus 6 is not under the square root sign, so I'm not going to be able to include it under that. So what I'm going to do is, first off, take the square root of 144 by itself. That's 12. And then I'm going to write down, bring down minus 6. Leave that in parentheses with the 3 outside because we're not finished until you're done with everything in parentheses, you don't want to drop those. So continuing on to finish out my parentheses, 12 minus 6 is 6. And then I've got a 3 on the outside, and anytime you have a number outside of parentheses, that means multiply. So 3 times 6 gives me the answer 18. So that is for that section. Okay, on the second page, this is where we get into our square roots. Number 4, the direction says each square root is between 2 consecutive integers. Name the integers. That just means 2 whole numbers in a row. Consecutive means in a row, like 9 and 10, or 14 and 15. So all we're going to do is take number 4, square root of 10. We're going to punch that in the calculator. Square root of 10 in the calculator is 3.16227766. So that would be between the 2 consecutive integers 3 and 4. Okay, number 8, approximate, that means round each square root or cube root to the nearest hundredth. Hundredth is 2 places past the decimal. So the first one is the square root of 32. So I'm going to put that in the calculator. And if I round that 2 places past the decimal, it will turn out to be 5.66. Let's do a cube root. Let's do number 11, the cube root of 25. If I do that in the calculator, then I'm going to get whoops, I turned my calculator off. Cube root of 25. I'm messing that up, I think. Whoops. Okay, so I'm sorry. For the cube root of 25, I'm getting 2.92. And if you can't remember how to put those in the calculator, refer back to the video on the lesson where I put the YouTube video of how to enter roots in the calculator, and it will show you how to do a square root and a cube root. Okay, put the following numbers in order from least to greatest. So let's do 14. Square root of 6, 3.5, and pi. So I need to get all of those in the same form. So let's start out by converting them all to decimals. So the square root of 6 is 2.44948997. I'm going to stop there because I don't think I need that many places. And then 3.5 is already a decimal. And then pi is 3.14. And I don't need to go any further because it doesn't, I don't have anything else that's close. So to put those in order from least to greatest, looks like square root of 6 is 2 point something. That's going to be the smallest. The next smallest would be 3.14 because the 1 is smaller than the 5. That's pi. And then the biggest in that set is 3.5. Okay, down at the bottom, write each decimal as a fraction or mixed number in simplest form. So I'm going to do 16. 0.5 repeating. You can put that in your calculator, or you can choose to set it equal to x and follow the steps that I showed you in the lesson. But we know that when only one number repeats to the right of the decimal, and that's everything is repeating to the right of the decimal, then what's to the right of the decimal is my numerator, and my denominator is 1 less than what it would normally be. This is the tenths place. So 1 less than 10 is 9, and that's in simplest form. So my decimal is 5 ninths. Again, you can put those in the calculator if you'd wish, and convert those into fractions that way, or you can follow the steps in the lesson that you learned. Okay, and the last page. These are some equations that are to be solved using square roots and cube roots. So let's just look at 21. It says solve it. If x squared is equal to 64, you would solve for x by doing the opposite of square. So you would square root both sides. When you do that, the square root of x squared cancels those out and leaves x. And the square root of 64 is 8, but in this case it could be a positive or a negative 8. So I'm going to put plus or minus 8. 24 and 25, similar things. Just be careful to watch if you've got a cube and you want to know the length of one edge, or if you have a square and you want to know the length of one side. That's where you do the cube root or the square root to find that. And that's it. So if you should complete this, and if you have any questions, let me know, and then you should be ready for your test.